Hello everyone, welcome to the part 2 of Codasip video blog on understanding the processor PPA. My name is Filip and I'm still here with Pavel Schnobel, who is the leader of the compiler group here at Codasip. In the previous part, we have covered how processor performance is measured using benchmarks and how compiler is affecting the processor performance. We have also explained that it is not always wise to blindly follow the benchmark scores. Actually, it is much cleverer to find different ways how to optimize the processor performance, such as moving away from the general purpose domain into the application-specific processor domain. Such thing is enabled by using Codasip products, especially Codasip Studio. And it wouldn't be very kind of me, since I have Pavel here today, not to ask him how the compiler development here in Codasip is allowing us to offer such simplicity when designing application-specific processors to our customers.
Well, when you typically optimize a processor for an application, you do so by adding custom instructions to the base instruction set. So you add custom instructions that are used to accelerate the most intensive or crucial part of your application. So when you add these instructions to your core, the question is how you actually use these new instructions in the application, how you use them to accelerate the application. So one way is to modify the application and add inline assembly statements. You basically use these inline assembly statements to insert the new instruction or instructions to the most intensive parts of the application. But this can sometimes be sort of ugly because you have to modify the application and then you have to somehow check that the application still works as it did before. And there is also a portability issue. So once you modify the application and use the custom instructions manually, you can no longer compile and run this application or on a different processor that doesn't have these instructions. So another option is to have a compiler that is aware of these new instructions and can use them, and then the compiler will automatically insert these new instructions on the places in the application where you expect them. And then you don't have to rewrite the application, you just need to recompile it with the compiler aware of the new instructions.
Yeah, that is very true. However, designing a compiler is like pretty complex thing. There are many companies who have a group of IP designers, and these people can create an application-specific processor, but designing or implementing a compiler for such processor requires completely different skill set. And if you really wanted to do it, you would be almost looking for two groups of developers, one working on the hardware of the processor and one working on the compiler, right?
Yes, that's true. I mean, I think that this is one of the biggest advantages of choosing to design your processor using Codasip Studio. I think that it would be the best if I showed you on a slide. So Codasip Studio is basically an integrated development environment in which you describe your processor or your instruction extension in a high-level architecture description language called Codal. And from this description, the tools embedded in Codasip Studio will automatically generate an HDK and SDK for you. So the HDK contains, among other things, an RTL for the processor described in Codal. And SDK contains a C and C++ compiler that is aware of all the instructions you described in the Codal model and can use them automatically. So you don't have to write a compiler, it gets simply generated for you. And as I mentioned previously, you don't just have to recompile your application and the instruction will be used automatically.
Thanks, Pavel, again. I think it's nice to understand now how we can go and create an application-specific processor with custom instructions in very easy to use way. That's great. But is there a way how you can also demonstrate how customers using Codasip Studio would benefit from having custom instructions in their processor?
Yeah, sure. Let me demonstrate with another example. So using the previous example, or the first example we had today, let's say that you want to add a MAC instruction, and this instruction, as its name suggests, will do a multiply and accumulate operation. So now instead of having to use two separate instructions, multiply and add, you just need to use one, which is the new MAC. So on this slide, you can see that if you compile the application from the first example using a compiler that is aware of the MAC instruction, you now have just a half of the instructions necessary in order to do the multiply and accumulate operations. So instead of having to use 4 multiply instructions and 4 for additions, which is like 8 instructions in total, you now just need to use 4 for multiply and accumulate instructions. So the compiler will do this automatically, and code size will go down because you're now using less instructions to do the same thing, to execute the same program. And when you have smaller code size, you need smaller memory to fit your application in. And when you have smaller memory, you can have also smaller area. And since you now need to execute fewer instructions in order to complete a program, the performance usually goes up. And since you're executing fewer instructions, the power consumption can also go down. So this way, when you add a new multiply and accumulate instruction, in this example, all these metrics I just mentioned will improve.
Thank you again, Pavel. It was really clear, at least to me, and I hope to everyone watching this video blog. It was nice to go all the way from discussing the conventional ways of how performance is measured to actually giving some advice on how can we focus on actually optimizing our processor solution for a very specific application, which is a really good way how to improve the performance. So really, thank you for joining. It was nice to have someone from our R&D on this video blog.
Yes, thank you, Philip.
And definitely visit our website. You can find all the information about the products we have been discussing here with Pavel today. You can also find links for other blog posts there, so you can read much more about what Codasip can offer. Thank you for attending.